So let's talk for a bit about rates of change and units. On number 27, if you're driving in a car traveling at a constant speed of 55 miles per hour, how far will you travel in 2 hours and 15 minutes? Nothing too terribly tricky here, but what I want to point out and talk about here is the speed, the 55 miles per hour, which we call a rate of change. You may remember, of course, in algebra talking about slope as a rate of change. Rate of changes are super important in mathematics and in science as well. And there's an entire branch of mathematics that deals exclusively, not exclusively, but extensively with rates of change, and that's calculus. And you might be fortunate enough to take calculus before you leave high school here at Guy. Now, you also might remember a formula from either science class or in a math class, which is the distance that you travel is equal to the rate that you're traveling in and the time that you travel. So, as a super simple example, let's say that you're going 60 miles per hour. Usually that's how we write miles per hour, right? MPH. But it might be more useful to write it as a fraction like this, miles, and then per means division, and then it's basically 1 hour. Okay, and if I multiply that, let's say that I travel this rate, this speed, for exactly 1 hour. So if I multiply this by 1 hour, think of this also as a fraction, where I put this like, let's say, over 1. And now if you take this hour that's on top here, and you divide it by this hour that's on the bottom here, they cancel out. And this is kind of an element of unit analysis that's super helpful in both a science class and a math class. And here's why, of course, this formula makes sense if we're talking about, let's say, just the units here. If I multiply this rate, which is in miles per hour, times the number of hours, these hours are going to cancel, and it just leaves me with miles left over, which is what the units should be here for the distance calculation. Now, there's a little extra complication in this one, and miles per hour, like this 55 that's here, it says hours specifically. It demands that you have hours for your time, but your time here is given in both hours and in minutes. So you'll have to deal with like how to get those into just hours. Not terribly difficult. I would just suggest taking those 15 minutes and using some sort of decimal or fraction in order to combine it up with the 2 hours that's over here. Okay, so some more stuff about units, specifically about unit conversion over here on number 28. Convert 55 miles per hour into feet per second. So I'm going to come down here and talk a little bit about units like this. Tell me this, is the number 1 over 12 equal to 1? Well, obviously that is not true, but what if I did this? What if I took 1 over 12 and I changed it up by putting in feet up top and inches on the bottom? Now, is that equal to 1? And it is. And the reason why it's equal to 1 is because this is the same quantity. 1 foot is the same length as 12 inches. The numbers don't look like the number 1, but they change, the context of them change with these units in here. And you remember probably in a previous one of these review videos where we talked about a fancy 1, what number can I multiply a quantity by and not change its actual value? And that's the number 1. Whenever you do a unit conversion, essentially what you're doing is that you're multiplying by a fancy 1. So let's talk about some conversion factors. Conversion factors are what are going to be helpful for me to turn one kind of unit into some other kind of unit. One of them is the one that we're talking about right here. That's, let's say, 1 foot is equal to 12 inches. You might have, let's say, 3 feet is equal to 1 yard. You might have 1 inch is equal to 2.54 centimeters. And the one that you probably need here for our question number 28, we want miles. And miles over here needs to be turned into feet, which means that we need, if you don't know this, 5,280 feet is equal to 1 mile. Of course, you could just search that up if you didn't know it. And then, of course, one that's kind of straightforward. You don't have to look this one up, I hope. 60 hours into seconds. Now, you want to do actually a couple of conversions here. Most people don't go straight from hours into seconds, so that you can. Instead, it's more like 1 hour is equal to 60 minutes. And then 1 minute is equal to 60 seconds. So let's say, for example, we're going to deal with these two right here, these two at the bottom. I'm going to show you a way of doing unit conversion that we do up here in our science classes, and they usually call it train tracks. And honestly, I don't really know why it's called train tracks because it doesn't look like them, but we'll just go with it. It's a super helpful tool to help you keep track of your units whenever you're doing conversions. So let's say that what I want to do here is take this 1 hour and I want to turn this into some number of seconds. Okay, so I'm going to start with my 1 hour. 1 hour. And I get to multiply this by the number 1, and I cannot change its value. If I multiply by 2, of course, it's twice as big, but if I multiply by the number 1, it doesn't change its value. So I'm going to multiply this by this thing organized as a fancy one, just sort of like what I did right up here, but I have to make sure that it's in the correct order. Okay, well, actually, it's not even going to be that one yet because this one doesn't even have the hours that I need. I actually need to start with this one, obviously. Okay, I've got 1 hour and is equal to 60 minutes. So here's how I can arrange this. I can multiply this by, I'm going to write this thing as a fraction, 1 hour over 60 minutes. And remember that this, again, is our fancy one. But I've got kind of a problem here. Thinking in terms of units, if I'm going to multiply these things as fractions, I put a little dot here for multiplication. I'm multiplying, you can think of this as a whole number, multiply times a fraction. If it's helpful, you can, of course, put this over the number 1. And multiplying fractions, top times top and bottom times bottom. I don't really care about the numbers here. What I want to focus is on the units. If I multiply hours times hours, think of it like variables. That'd be x times x, which is x squared. This would be hours squared, which is, super unhelpful. So what that means is that I've got this thing upside down. I've got my conversion factor upside down. I'm going to flip it. And it doesn't matter that I'm going to flip it because it's still on the number 1. And what it's going to do is it's going to put my units in the opposite locations, which is going to allow them to cancel. So now, this time when I multiply it, I am going to put the hour on the bottom and then the 60 minutes on the top. Now we can easily see that this hour and this hour are going to cancel each other out because hours divided by hours, just like 5 divided by 5, is the number 1, right? So they would just kind of cancel out just like this, boom and boom. And now whenever I go to multiply this together, of course, this is very straightforward. I'm looking at a very simple example. And whenever I'm done, I'm going to see that, of course, when I multiply the numbers together, 1 times 60, I get 60. And the only units that are left up top is minutes. And if I look at the bottom, it's 1 times 1, and this hour is gone, so I don't have to worry about it right here. So 60 minutes. But like that makes sense. That was, as part of my conversion factor already, that 1 hour is equal to 60 minutes. However, what I'm showing you is that now I can apply this in a more complicated way. If I have multiple conversions to do, this is what we ordinarily set this up like. And this is where the term uh, train tracks comes from. So the way that we do this up here in our science classes is that we organize this. It sort of looks like a T-chart like this. And it is just a device, a tool to help me organize my conversion factors. Whatever it is, kind of the principle here is whatever it is that I want to cancel out, you want to make sure they're in opposite quadrants here. One up top and one on the bottom. I want hours to go away, so one has to be on top and one has to be on the bottom. And the benefit of this is that you can string together as many of these as you possibly want. So now let's go back to this question here where I'm taking hours and turning it into seconds. So I need to go into minutes first, and then from minutes I can go into seconds. So I'm going to set it up exactly the same way. I'm going to start with 1 hour, open up my little train tracks here, and I first need to get hours to go away. So that means that hours need to be on the bottom, and then whatever it converts to needs to be on the top. So my first conversion factor is 1 hour is the same thing as 60 minutes. Okay, but I want to keep going. Sure, my hours cancel out, which is what I wanted to happen. Boom and boom, and I just have minutes. Now I'm going to use my next conversion factor. I'm going to put it on the next part of my little T-chart here, my trade rocks. Okay, and again, I want minutes to cancel out. If minutes are currently on the top, then I need minutes on the bottom, and then whatever it converts to goes on the top. So my conversion factor is right up here in green. I've got 1 minute is equal to 60 seconds. So I'm going to put 1 minute on the bottom and then 60 seconds, what it corresponds to make our fancy one on the top. And then again, we can see that the minutes and the minutes here cancel. And if you look at the whole entire thing, you can see that the only unit that's left over is seconds, which is what we want. So now multiplying all your numbers, you multiply, again, you can think of these as fractions, all the tops multiply together and then all the bottoms also multiply together. So we have a total answer here of just 60 times 60. You can do this like so, 60 times 60, bring down a zero, and then you've got 3,600 seconds. So that makes another conversion factor. If you wanted to go straight from hours into seconds, that 1 hour is equal to 3,600 seconds. Which brings us, of course, to the question that you have up here on number 28. Whenever you go to set this thing up, you would want to start it off with 55 miles on top, and then the per hour, think of that as 1 hour, and then you're going to start your conversions here. You want to first get rid of hours. Well, actually, I take that back. You can get rid of miles if you wanted to get that into feet, or you could get rid of hours first. It really makes no difference. But in your next little quadrant here, you're going to put your conversion factor, and let's say that you're going to get rid of hours first. If hours are on the bottom, that means an hour needs to be on the top, and then whatever you're going to convert it to on the bottom. It could be seconds, as we just did, or you can go into minutes, get rid of the minutes and turn that into seconds, and then so on. Then what you want to do is get rid of your miles. Miles are on top, which means that you need miles on the bottom, and whatever it corresponds to, feet in this case, is going to go on the top so that the miles cancel out. Give it a try.